Hey everyone, this is Scott again for part 2 of my services tutorial. So this is going to be a little more of an advanced one. If you haven't seen part 1, I'd recommend watching it because we're going to pick up right where that left off. But just to recap, services have long-lived state. They can store things for us and then we can access those things anywhere. So the example that we had was for logging people in, so a session. You know, a person is logged in. They are logged in no matter where they are. We can access that session anywhere. And another thing was for when we have routes that require authentication, we redirect when they try to log in. And then when they do log in, we take them back to where they wanted to go. So one of the other things that goes along those lines, you know, deferring a transition was kind of one of those common problems that people don't think about necessarily, but it is kind of expected behavior. And one of the other ones is inactivity. So if I have this app and the person logs in and then they just sit at their computer and don't do anything for 20 minutes or a half hour, however long you want that to be, do we log that person out automatically? Because by default, this session is going to stay open forever, right? And that's kind of weird behavior. Because I've worked on apps where people put in financial information, so obviously we don't want them to just leave that up if they walk away from their computer. We actually want to kill that session for them. So that's what we're going to do. We're going to create an inactivity monitor, and we're going to go over how to test that because it's actually really hard thing to test. And I haven't really gone over tests in any of my tutorials, but my life is pretty much writing tests, where probably 75% of my coding time goes. So this is one that took me a while to solve, so hopefully I can help people out if they run into similar problems. So we're going to start by generating a new service. Ember generate service inactivity monitor. Cool. So let's go and take a look at what Ember created for us. So here's my little default service. So if you've watched any of my other videos, you know I like destructuring stuff. I think it makes it so much easier to read. And we're going to do this for lots of different things that we import from Ember. So writing this const and then destructuring service equals Ember is the same as doing like var service equals Ember.service. If I could spell it right. Just the shorthand way of doing that. And when you want to pull multiple properties from an object, then you can do a comma separated list. So inactivity. So what would be inactivity? I literally just sit idle for X amount of time, and you log me out. So maybe we have an inactivity timeout. Let's set it to null for right now. So this will be the amount of time that has to elapse before I get logged out. What else will we have? We would have user events. So these are the things that the user can do to reset that inactivity timeout, right? Because I only want to log them out if they don't do anything, but if they're typing and clicking around, then it doesn't make sense to log them out after 20 minutes. So what would our user events be? These would be window events, so mouse move should cover it. If they're on a smart device, touch move, and key down, right? So they press something on their keyboard. So if they make any of these actions, right, they shouldn't be logged out. It should only be if they don't take any of these actions for X amount of time. So anytime they take one of those actions, we should reset the timeout, right? So this will be the function that resets this timer for us. But we should also set up our window events. So right now I just have an array of strings. So when the application starts or when the person logs in, we actually want to set up these events. So what else do we want to do here? If you watched the other video, you know we have a session service that checks to see if the person's authenticated. So that kind of makes sense to pull that in. So we can pull in inject service from Ember because I can't log people out if they're not logged in. So we should have a check in there that actually makes sure that the person's logged in. So session is a service that we're going to pull in. Cool. So let's start by setting up these window events. So let events equals, we're going to use Ember's get here because we want to get a property. In this case, we're going to get user events, get this, which refers to our service, user events. So we're going to go over this list, and we're going to create a bunch of window events. So we're going to map these. So for all user events, we're going to map and call them event. And we're going to return the name of the event. And we're going to namespace these events to inactivity monitor. So this is namespacing it to window, so window.inactivity monitor. And we're going to do this so that we can destroy these window events when we log the person out, or if the person logs themselves out. We obviously don't want to keep tracking all this stuff, so we're going to namespace it so that we can easily clean everything up when we're done. And we're going to join this list, separating it by space. So then we are going to pull in window, and then on events, which is this, right? We're going to go on all of these actions that we're taking here. We're going to do something, right? So that something is going to be resetting our timer here. So we can, for now, just call reset timeout. It does nothing, but this is essentially what we're going to want to do. So anytime somebody takes one of these actions, whether they mouse move or they press the key down, they're going to take this action, and let's log it here. We are resetting the timer, right? So we're going to essentially have a timer object, right? So inactivity timeout is the amount of time we want to wait. It's going to kind of like be a constant, and then we're also going to have the thing that's tracking it, right? So that's our timer. So let's just call it our timeout timer. By default, we'll set it to null. All right, let's save this. So how do we access this? So right now, all it's doing is creating window events. So we don't have any logic in place that checks to see if the person's logged in, and we don't have anywhere where we're actually setting this stuff up. But just to kind of play around with it, see if we've done at least this part right, let's inject this service into our rentals route and see if we can see this console log got fired. So let's go to our rentals route here. So here we had that deferred transition, we had that login user action. So now we're actually going to have an activity monitor, which is also a service. So when the person logs in, we want to set up those window events. So when we log them in, we can do get this inactivity monitor. So this being our route, inactivity monitor being the service we've injected into it, and then we can do set up window events. Cool, should be as simple as that, right? So if we bring up our console here and I log in, look at that. I mouse move, I click, I do all this stuff, and it's firing. We are resetting the timer, right? It's tracking my actions. But that's kind of absurd. That's actually a lot of actions to be taking, right? We don't necessarily want to track that much stuff. 214, we fired that function 214 times in just a matter of a few seconds. It's kind of absurd. So let's see if we can handle that a little bit better. So let's take a look at what we have again. So on those window events, we just call this function. It'd be kind of nice if we could call this function once every maybe half second or something like that. So if you've watched my video on the Ember run loop, you probably know there's actually some pretty easy ways that we can do this. So let's kind of hop into importing some things from Ember run. So one of the things that we can import from the Ember run loop is a function called throttle. So we can actually throttle a function and tell it only to run once within a certain span of time. So reset timeout is actually a great example of something that we can throttle. So let's pull in throttle. Throttle expects 3 arguments: the context, which is our service object, the function name, or the thing that we want to do, in this case reset timeout, and the amount of time in milliseconds. So half a second here. So now, theoretically, anytime any of those actions happen, we should be throttling it for every half a second. Let's see if that actually works. So let's clear out our console. We'll log the person in. And there, we only actually got it 5 times. So we only got it for every half second, presumably 2.5 seconds went by. So we throttled that action. We know we're not going to be watching it constantly. It's kind of up to you how wide of a buffer you want there. I think half second's probably decent. If you go longer than that, you run the risk of accidentally logging the person out when you shouldn't, because the timer was too long. Kind of depends on how long the timer is, but you know, maybe we can make it a second, and that's makes a little bit more sense. So we're going to throttle the reset timeout action, right? We're not going to call it every time the person does something. We're only going to call it once per second for every time somebody does something. So we're making our application slightly more performant. So what is the reset timeout going to do? Well, first, it's going to look at how much time we should wait. So let's set this to something random, 100 seconds. So it's going to get that inactivity timeout equals get this inactivity timeout. So it's now gotten the amount of time that we want to pull in. And then after a certain amount of time has passed, it wants to call a certain action. So reset timeout just is going to reset the timer for us. But we also want to have an action for when the person has become idle. Since it's an inactivity monitor, the person did become inactive. So this will be the thing we do once that timeout has been set. They've been sitting there for too long. We're going to take some sort of action. For now, we're going to add a console log. They became idle. So one of the things we did here from the Ember run loop is run throttle, which was run this. I want to run this function, but I don't want to do it more than once per this span of time. So now what we want to do is run a function after a certain amount of time has passed, right? In this case, we want to run did become inactive after this much time has passed by. So you can actually use what is called run.later. It's very similar to set timeout. So later also accepts a context, which is this. It accepts a function, which is did become inactive, and it accepts an amount of time. In this case, the inactivity timeout, which is our 100 seconds. So let's reduce this down. Let's make it 5 seconds just so we can actually track this. So after I have logged in, we're going to set up our window events. It's going to throttle how often reset timeout is. So after I move my mouse, it's going to call reset timeout. Reset timeout is going to look at the amount of time it should wait, and after that amount of time has passed, it is going to run this did become inactive. Let's clear out this console log so we can clear up our console. So we should see this fire after 5 seconds of inactivity have passed, right? So let's clear you out. Actually, let's refresh just to be sure. Let's clear our console, and let's log in, and we will just come over here. There, 5 seconds have passed. They became idle. Right, our function just has a console log, but we'll take care of actually logging the person out. Cool. So that worked really well. So let's test that one more time. So let's clear this. Let's log in. I'm moving my mouse around a lot. I'm waiting. Maybe I'm typing some stuff. Blah, 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 blah. But then it still called that action, right? So we set it to run later, but we actually didn't tell it to cancel this. So the first time reset timeout was called, sorry, I'm just commenting that out because it's going to keep trying to run that function. My computer's getting loud. The first time we run this, it sets up this later call, and then it waits that amount of time, and it calls it again. And then when I move the mouse, the reason we saw the console log like keep calling that console log over and over again is because every time I move my mouse, it set up another one of these laters. That's bad. We don't want to do that. So what we want to do is we want to cancel this timeout if this function gets called again. So run.later actually has, or excuse me, Ember run has a function called cancel. However, in order to do that, we need to have something outside this function that we can access to cancel. We can't keep doing it within this function because then the function is destroyed. We run into this weird scope issue. So that is when our timeout timer comes into play. So that timeout timer equals this. So this is again just happening within this function, and then we're going to use Ember set to set that property. Set this timeout timer. So we're setting this here to be our local variable of timeout timer. So now we have this property set here, so we can then cancel get this timeout timer. So when we call this function again, it's going to look at this and it's going to cancel any run action that it had, in this case the later run that we had within there. So let's save that and see if it does what I hope it's going to do. So if I log in and if I keep moving my mouse around and I keep clicking on stuff and I keep clicking on stuff and I'm looking at my console over there, I don't see anything actually popping up because I keep clicking. But if I sit idle for 5 seconds, it logs me out. It calls that they became idle, did become inactive function. Right? That's pretty cool and pretty simple with the Ember run loop. I want to run this function later. Much like all the other things in our services, we're setting properties that we want to access later. So let's set that timeout timer to be this run later action. And then if I ever have to call this again, because it is a reset timeout, I'm resetting that timeout, I'm going to cancel that timer, and then I'm going to create a new one. So we don't run into this issue where we have a bunch of different actions getting called. So we're throttling how often we call this function. I don't want to call it more than once every second. And then I'm going to make sure that I don't have duplicate timers out there. We're only ever once watching one timer, which is this timeout timer here. Cool. So now let's actually handle the action of logging the person out. So obviously, if the person isn't logged in, we shouldn't log them out. And if we don't have a timer set for whatever reason, we shouldn't log them out. And I'll go over why we might not have a timer set. So I purposely injected the session service when we first built this, right? Because we kind of knew that we needed to check that. So let's pull that in. Let session equals get this session. Then if session dot is authenticated, right? That was a function that we wrote. Let's pull that up real quick. Session service is authenticated. Actually, let's delete that. Don't need that anymore. Make sure I copy that right. Cool. So if the person is authenticated, we are going to log them out, right? We might as well have that check. It doesn't make sense to do something if they are not authenticated. And we can just call this logout function. And just to be sure we hit it, they have been logged out. So if the person is authenticated, session dot logout. Cool. Let's try this. Increase that. So I'm going to log in. You are logged in, true. And I'm going to not move my mouse or do anything for 5 seconds. Look at that. They've been logged out. That's the action called from, or that's the console log from my service. And then it also hid that conditional if block that we had that tells me if the person is logged in. So we actually waited an appropriate amount of time and we logged the person out. I moved my mouse around. That delayed the timer. It only logged me out when I was inactive for 5 seconds. That's pretty sweet. So finally, one of the other things we want to do is a little cleanup. So within a service, much like within controllers and routes, etc., there's a function that's fired when you destroy something. And it makes sense that if this service gets destroyed, we should probably destroy these window objects that we had, right? We don't want to set these globals for whatever reason. Assumedly, the service would only be destroyed if our application is destroyed, so it shouldn't be an issue. But it's always good to just kind of have some cleanup, and that's actually why we namespaced this up here, so that we could easily clean it up when we were done. So to clean that up, we can call window.off inactivity monitor. Actually, there should be .inactivity monitor. So up here, oops, we called window.on events, which were namespaced to inactivity monitor. So now we're going to off all those inactivity monitors. Then if for whatever reason this is destroyed, we should also cancel this, right? We don't want to keep trying to attempt this function. We should cancel that timeout timer method here that did become inactive, because if this gets destroyed, it's actually still going to try to run that in the run loop because it knew to delay that action. So let's destroy that. But there's actually one thing that we should destroy that we're not even tracking right now. We should probably destroy this, right? It's a weird use case. You probably won't ever hit it, but if this got destroyed before this 1 second resolved, it is still going to try to throttle that function, and then you're going to get this weird error that you can't call this function on a destroyed object. So let's add something called throttle action. By default, that is null. And we'll do the same thing that we did down there. Let throttle action equals that. Set this throttle action to be throttle action. So it's still going to be doing what it did before. We're not going to see any difference. The only difference now is that if I destroy this for whatever reason, I can now cancel get this throttle action, and we've fully cleaned up this service now. There's no window events, there's no delayed functions or something like that, that are waiting to be called. We've completely destroyed this, and it's really clean for us. Cool. And much like other functions that inherit from the base class, we should call this super arguments. So if this inherited from another service, we don't want to completely overwrite the will destroy. We want it to inherit from its parent as well. Awesome. So that's just a little basic cleanup there. Cool. So we have this pretty much working the way we want it to. So one of the really annoying things that you might run into, though, is when you're in development mode, you might not want a timeout, right? If you're testing a bunch of stuff, sometimes you walk away from your computer for a while. You don't want to come back and have the user be logged out. That is why I would make this variable. So one thing that we can do based on where we're living is set this in the environment. So let's pull up our environment file. So within here, we can actually set like global properties within our environment. So one of the things that we might want to differentiate between is whether the environment is development versus something like a production. So we would set properties here in the app. So in this case, it's going to be a session timeout. That should be 20 minutes, right? That's kind of a good timeout amount of time. So when we are running the environment in normal production, when we're deploying it, it's going to be timeout. But if the environment's development, we need to pull in the environment .app session timeout, and we can set it to something, you know, ridiculous. So now we have this 20-minute timeout, which makes a lot of sense for production, but if I'm working it, I don't want to get logged out. Let's set it to something absolutely ridiculous, which is like 3 hours. And then similarly, we actually don't want to have this fire within our testing environment, because if you run application tests, you might actually not be triggering these events, and you might trigger an idle out. So let's actually set it to null, and then when we want to test it, we will explicitly set it on the service. So for by default in testing environments, when we run our test suite, there is no session timeout. We will explicitly test the session timeout ourselves, and kind of that should give us the test coverage that we need. We don't need this applied to all of our acceptance tests. Cool, so we have that set on our environment, but now we actually have to import that environment property into our service. So we can import environment from the config file, environment, and now this can be environment.app.session timeout. Cool, so now we have this 20-minute delay for production. We have this like 3-hour delay for development, and it doesn't even run for our testing environments now. So if you ever have to have something that's kind of variable like that, you want to set that in the environment config. It is dependent on our environment, so that's where that logic should live. Great. So now let's solve the problem of how the heck do we actually test this, right? When we generated this through Ember-CLI, it added a unit test for us. So inactivity monitor, let's pull this up here. So this is a unit test. If you're not familiar with testing in Ember, there's kind of 3 levels of tests. The unit tests are the most granular. Usually you test a function directly. I call this function, I expect this to happen. The next level up is an integration test, usually for things like helpers or components, but you can use them for services too. It's if I integrate this thing into my app, no matter where it is, does it behave the way I think it is? Like if I put this component on a page, does it do the things that I expect it to? Versus acceptance test, which is the highest level, which is supposed to usually be like mimicking user activity. If the user logs in and clicks this thing happens. So a little less granular than what we're going to do here. But for now, let's just focus specifically on the functions that we wrote. So one of the things that we have to test here is the amount of time that's lapsed. And it's a really hard thing to test, especially in JavaScript. And I personally always use sign-on when I test these things. So let's first start by pulling up this test in our browser, localhost 4000/tests. If you've never run tests, you can go to localhost 4200/tests. It's actually going to run tests for our whole application here. But we're just going to focus on a unit test for our inactivity monitor. By default, it passes because all it's testing is whether the service exists, and of course it exists. So that was going to pass by default. So I want to install sign, and actually, excuse me, it's called Ember sign-on. So sign-on is this really great library you can use for testing. It allows you to stub out functions and restore them. It allows you to pause time essentially and move time forward slowly. I use it all the time. It's great to track third-party libraries. So you have a component that's dependent on maybe like a Google API or something. You don't want to test the Google API, so you can use sign-on to stub out certain functions and just assert that those functions were called, and then I'm going to trust that Google tested their functions appropriately. So here we now have access to sign-on. Let's just kill our app real quick, and we will install just to be sure. And now we can restart our app. So if you're not familiar with testing, it can be a lot of fun to run your tests through the browser. If you're finding it not super performant, you can actually run your tests through your console through Ember test, and then it'll go through all these tests here. You can also Ember test filter by certain things like unit tests if you want to only run certain tests. It's usually a bit faster to run it through your console than through the browser, but the browser is nice because you can have some visual representation. So we installed sign-on, so let's import that. Import sign-on from sign-on. I know I'm going to be using a lot of Ember stuff here, so import Ember from Ember. So our test by default does not have access to Ember. And we're going to end up importing the run loop, because that's the thing that I actually want to stub here. So this is when it becomes kind of tricky. So let's go on and start with what do we want to test first. I kind of want to test this first. I want to test that it throttles this action essentially. So it's going to wait a certain amount of time and then it's going to call that action. And if I take an action like key down or touch move, it won't call that action after a certain amount of time. So setup window events is the function that we're calling. We're describing our test here, and it properly throttles an action. Okay, simple enough. So what is it doing here? So this .subject refers to the subject of our test. In this case, our inactivity monitor class. When you set this subject up, though, you can actually pass in properties to this actual service. So for example, if I want to overwrite user events, I can actually do that here. User events key down. So now it's going to set up the subject, this service, but it's now overwritten this one property. Everything else is going to get its own defaults, but we're going to overwrite this one property. So that's why I was saying we would set inactivity timeout to null on our test environments, because we are going to explicitly, oops, why can I never spell timeout? We're going to explicitly set it here. So we are going to manually pass it in when we want it. Otherwise, let's not even worry about it. So what are we really testing here? I want to test that after 1 second, reset timeout is called. So in this instance, I actually don't care what reset timeout does, right? We are testing this one individual function. And what does this function do? It tracks user events, or it creates an array of user events. When one of those actions happens, it resets the timeout after a second has passed. Kind of makes sense, right? So let's keep it to the scope of just this function. So what we're going to do is we're going to pass in some user events. We're going to trigger a user event. Then we're going to wait a second. And then we're going to make sure that this function was called. So similar to how we passed in user events here, we can actually stub out reset timeout. So let's do that. So let's create a function here. Let reset timeout, and that equals a function. So within your tests, you have assertions. Assertions want to return true, and they're asserting that something is true. So I'm just going to assert.ok. This function is called. So usually you don't see assert.ok true, because it's like, well, that's always going to pass. OK expects the first parameter to be true. So usually you would have some sort of property there, and it makes sure that either the property is present or that it's actually returning a Boolean that's true. But in this case, what I'm really testing is that this function got called at all. So let's set that up in our service. ES6 format is, if you have a key that matches the value name, you can actually just do that, so we don't have to do reset timeout : reset timeout. So what we're going to do is we're going to call our setup window event. We're going to wait a second, and then after a second has passed, the test should hit this assertion. That's essentially what we're doing. So how do we do that? Well, in order to control how much time has passed, that's why we actually brought in sign-on. Because by default, the test isn't going to wait a second for us. It's going to go through this synchronously because it's JavaScript, and then it's going to say your test failed. And then that second will pass, and then it will have been true. But by that point, the test had already failed us. Hopefully that sentence made sense. So what I want to do is I want to use some fake timers with sign-on, and that's really the big thing that sign-on does for us. It allows us to essentially pause the clock and then tick the clock forward. So in order to do that, we need to set up the clock outside of the context of our test. So here's this clock variable, and then here in the module for hook, we can have some hooks for before each and after each. What this means is it's going to do whatever, if I can spell it right, it's going to do whatever I put in here before each test, and then after each test it's going to do whatever I put here. So in this case we're going to use clock equals sign-on dot use fake timer, and that is a function. And then after each test we're going to restore that clock. Cool. So here we've set up our service, so now let's do service dot set up window events, and let's see what happens in our test. Sign on dot default use fake user fake timers, use fake timers, if I spelled it correctly. Cool. So it failed, expected at least one assertion, but none were run, right? It never reached this because we didn't have it past a second yet. So we've set up our window events. Now we need to trigger one of those window events, in this case the key down. So we will window trigger key down, and I explicitly overwrite it here. I don't think we need to test that all three of those work. Again, we're testing that setup window events can take an array of user events and create a bunch of window objects from that. So let's test this real quick. So our test passes. So what throttle does again for us is it runs that function, but then it makes sure not to run that function again after a certain amount of time has passed. So how can we test that? We only have one assertion, right? What we want to assert actually is the number of times this function is called. So we can assert.expect 1. What we're saying is I expect this test to have one assertion. In this case, it's this. So if I call you multiple times, throttle should have handled that appropriately. I'm doing key down 4 times, but because we're throttling that action, reset timeout should only get called once. And here it does. So how can we actually test that it fails properly if more than a second has gone by? That's when we can use our fake clock. Clock.tick, and let's tick it forward 2 seconds. So if I tick the clock forward 2 seconds and then have another key down action, we can see that assertion is actually called twice, but that the test fails because it expected one assertion, but it got 2. So we've kind of handled testing that the throttle in fact worked, right? We clicked twice, it only called that function once. We waited 2 seconds, then we clicked twice again, and it called that function one more time. So that's kind of what that fake timer does for us. We are asserting that this function is called the appropriate amount of times within a certain allotment. So if we change this to expected 2, it should pass because it did in fact run reset timeout twice. Cool. So that's what sign-on does for us there. So similarly, let's now test reset timeout. So we're going to write another test. Reset timeout. It resets our timeout and prevents logout. We pass an assert because that's what QUnit expects here. So what are we testing here? reset timeout. If there is a timeout timer, it should cancel it. It gets the amount of time, and then it sets that timeout timer for us. Cool. So much like above, we're going to mock out did become inactive. That's going to be a function. And we're going to do the same thing. Assert.OK true. User became inactive. Right? We're testing that this function properly gets called. And we're going to let service equal this.subject. And that's also going to get some properties. In this case, did become inactive again. Inactivity timeout. We're going to also stub that out again for 1 second. So now if I do service.reset timeout, I should get one assertion, right? Let's see what happens. Expected one assertion, but none were run, because I should have to tick the clock forward by 1 second, which I forgot to do. Cool. Reset timeout after a second calls that timer for us, right? So what happens if I click this forward, but then I call reset timeout again, and then I tick the clock forward a second, right? Does it still only get called once? It would also help if I spelled clock right correctly. Assert.expect. Again, I'm just expecting it to happen one time, and it does, right? Let's change this to 1500 or 1.5 seconds. So a total of 2 seconds have passed, which is enough time for that function to fire twice because we only have a 1 second delay. But reset timeout, again, it's resetting that timeout for us, even though a bunch of time has passed, because we waited half a second and then we reset the timer. It knew not to run that function for us again. So finally, let's test did become inactive. What do we want to test here? I want to test that it calls session.logout after it's called. And it conditionally does it whether it's authenticated or not. So let's begin testing that. Test did become inactive, logs user out through session service. And that's a function. We can assert that. So this one's a little different because now we're actually depending on a different service. So how do we do that? We can actually create a service stub here. We'll call it session stub, and that is a service that we extend just like we would when we're creating our own service object. So in this case is authenticated. I want it to return true in this case, and we have this log out function, right? And similar to above, I want to assert.OK. We're asserting that, you know, this was called. Or we can do something more descriptive to that. User is logged out. Cool. So here's this service object. How do I actually access it in my test? We actually have to register this service. So this dot register service session, and we are passing in this session stub. So we're going to register a service called session, and it's going to be that. And then we're going to inject that service session, or excuse me, we're going to inject session, and then expect the hash. How are you injecting it? We're injecting it as session. Cool. So this is allowing us to really call it the same way it's calling that that function within the inactivity monitor service that we wrote. And again, I don't care that logout actually does anything because our service really isn't aware of what the other service does. I just need to make sure that it's calling the right function here. So if we do service dot did become inactive, and we assert.expect1. That should work. Service is not defined. Yes, service is not defined because I didn't set it up. Service equals this dot subject, and in this case I don't think we actually need to pass anything in. It's not stubbing anything out. So this should actually be a function. And we can actually test this too if we want. Why is that indenting weird? Assert.OK, true, check authentication. Cool. So now we've tested that did become inactive, checks whether the user is authenticated, and if so, properly calls the logout function. So similarly, we could test, if we just copy this test and had did authenticated return false, we should get one assertion. It should not call the logout function, which it did. So that's some kind of granular testing in a nutshell. You might want to write some broader tests in terms of like acceptance tests. But you know, I think sign-on is a really good tool to have on your belt, especially when you're dealing things with like timers. You can also completely just stub out certain functions. But you know, unit tests can be pretty simple. A lot of people kind of get worried about like testing the whole essentially class from a function. But I kind of urge people, you know, focus on just what this function does. I pass it in certain parameters and conditionally expect this function to call something else. Doesn't matter what that something else is. Let's test that something else separately. Let's make sure that thing is handled. Let's just make sure this one function in particular kind of does what we expect it to do. And there's lots of different ways to do this. I did this weird little assert OK thing. You could actually use sign on to spy on these functions, and then you could just assert that they were called once. That's kind of what we're doing here. This is just a different way of doing that. Yeah, and there's more than one way to skin a cat, they say, so there's always going to be different ways to test these things. So if you had any ideas or wanted to see it tested in a different way, you can definitely let me know in the comments. Happy to hop into some examples for you. You know, timers are always a tricky thing to test for, so I thought I'd show one example of how we can do that. But definitely there's a ton of different ways and a ton of different libraries you can use too. So hopefully you found this super handy. Inactivity is a weird problem to solve, but you can kind of do it pretty easily through these services. So it does kind of look like we wrote a lot, but you know, it really isn't that complicated. When you step through it piece by piece, we have some window events. When those window events happen, we want to reset our timer, and our timer is the thing that waits a certain amount of time, and if that time has passed, it logs us out, right? So we wrote a bunch of different services. We wrote a session service that logs the user in and stores a session. We had written in the previous video a service for transitioning the person if they try to go to a route that requires them to be logged in. Let's make sure we take them back there once they do log in. And then we did an inactivity monitor. It tracks inactivity across our application, right? Has long-lived state, and if the person's inactive for a certain amount of time, it logs them out. Cool. So thanks for watching. If you liked it, subscribe, give me a thumbs up. If I missed something, definitely let me know. Happy to always maybe mock up an example or help people through stuff. So thanks so much.